So the topic is probability. See, what do you mean by probability? Probability means chance. Okay. That means chance of something happening. For example, if I speak about probability, probability of some event E is equal to outcomes by total outcomes. Outcome by total outcomes. That means favorable number of favorable cases divided by total number of cases. For example, if you toss a coin, what is the probability? So there can be a head or there can be a tail. That means when a coin falls on the ground, either you see head or you see tail. So there can only be one outcome, that is one outcome only out of these two. Both of them cannot fall. That means when a coin falls, both the faces you can't see, you can see only one face, and there are how many faces for this? Two faces. So 1 by 2 is the probability. Point number 2, to just justify this formula. When you throw a die, only one face you can see out of 6 faces. 1 by 6 is the probability of throwing a die. When I speak about like pack of cards, so what do you mean by pack of cards? There are a pack has how many cards? Anyone? There are 52 cards. Okay, just a second. So this 52 cards we can divide into 4. Like one is, we can divide into 2 colors, black, red. Black you have spade, now see, when you do an experiment is also called as trial, and the outcome of this trial, that means you are tossing a coin. Tossing a coin is an experiment as well as a trial. But when outcome you see, outcome can be head or tail. That is nothing but event. And if you have to find out the probability of any event, that is 1 by 2 in case of a toss of a coin. Okay. All of you make a note of this. Then we will discuss about some of the more points. So if I have to say event is nothing but possible outcomes of a random experiment. What did you do? The experiment is nothing but the experiment here. What we are discussing is tossing of a coin, and this tossing of a coin can have any possible outcome, either head or a tail. Okay, fine. Anything if it comes either head or tail, that can be termed as an event. So next, mutually exclusive. Mutually exclusive events. See, mutually exclusive means two or more than two events are said to be mutually exclusive if they cannot occur at the same time. I'll give you a very good example. So if you are going in a car, this is a car, this is right and this is left lane, right lane and left lane. Now can you tell me, if the car is going right, can it go left? No. So two or more than two events are said to be mutually exclusive if they cannot occur at the same time. See, right turn and left turn cannot occur at the same time. Right turn and left turn cannot occur at the same time. That means car can go either right or left. It cannot go right and left at the same time. Understood fact? If you toss a coin, only head or tail can fall. Both the sides you won't see on the fall of the coin, correct? So example, car can take either a right or a left turn. And point number two, when you toss a coin, tossing a coin, head or tail are mutually exclusive. Okay, all of you make a note of this. हेलो, यश कहाँ पर हो? ऑनलाइन नहीं है? हाँ, ओके ओके, आ जाओ आ जाओ, ओके ओके, वेट करो, राइट राइट, प्रोबेबिलिटी, राइट राइट। तो फिर तुम मॉक करते क्या बैठ के? तो मॉक एक भी अब तक मतलब मॉक्स वगैरह नहीं कर रहे क्या, लाइक सेक्शन वाइज टेस्ट नहीं कर रहे? तो यश एक काम करो ना, अपने डे को डिवाइड करो। Hello. Yeah, actually, this is getting stuck. Just wait for 2 minutes.
Okay, sir.
I'm very much. This is troubling a lot actually. Everything goes in good rhythm. Again, this disturbs. See, to all the students, what I'm saying to all of you is practice. Today, I have sent the permutation combination questions. Start doing them. Got stuck. Okay, let's start. So, mutually exclusive done. Now, equally likely events. Equally likely events. So, what are equally likely events? See, two or more events are said to be equally likely. That means if you toss a coin, there can be a for if the coin falls, there can be a head, there can be a tail. That means any of the two things are possible. So when you toss a coin, there can be either a head or tail seen on the fall. That is equally likely. Okay, that means 50% chance that head can fall. That means that you can see head when the coin falls, and 50% chance that you can see tail when the coin falls. Next point. Next one is exhaustive events. These are all important terminologies in probability. So events are said to be exhaustive if at least one of them must necessarily occur. Okay, events events are said to be exhaustive if at least one of them must necessarily occur. Okay, so for example, in throwing a dice, the exhaustive events are 1, 2, 3, 4, 5, 6. That means at least one of them may fall. All of you make a note of this. Okay, now next point. Independent events. Almost we are about to end the theory and then start the questions. So what are independent events? See, events are said to be independent if occurrence or non-occurrence of one event does not influence the occurrence or non-occurrence of another event. I will give you an example, don't worry. Occurrence or non-occurrence of one event does not influence the occurrence or non-occurrence of the other event. Okay, so independent events are said to be independent if the occurrence or non-occurrence of one event does not influence the occurrence or non-occurrence of the other event. Okay, so I'll give you an example, just check it out. See, if a fair coin is tossed twice, the head in the first toss and the event head in the second toss are independent. That means it is not necessary that first toss if you are getting head, second toss if you are getting head, they are interrelated. No, they have no relationship. Fine, it is just a coincidence that head falls and then head falls. Fine. So I'll write the example. See, if there is for example, if of one more independent event I can give, what we can say, you wearing a blue dress, okay, you wearing a blue dress and going to the college, fine, and there may be a dress code, there may not be a dress code. You wearing blue dress like is independent of whether there is a dress code or no dress code. Fine. One more example we can take of independent events. One more example, rain falling in Hyderabad and rain falling in Mumbai are independent of each other. Why? Rain falling in Hyderabad and rain falling in Mumbai. See, Mumbai is far away place from Hyderabad. If rain falls some 100 kilometers to Hyderabad, we can say in Hyderabad also rain can fall. Mumbai is some 800 to 900 kilometers away from Hyderabad. So falling of rain in Hyderabad doesn't have any. Achha, okay, let it be. Falling of rain in Hyderabad and falling of rain in London. Do they have any kind of dependence? Please tell me yes or no. These are independent events. Why? London is in Europe, Hyderabad is in Asia. It is a mere coincidence that rain is falling in London and rain is falling in Hyderabad. There is no dependency. If at all I have to say, if I have to say, like rain is falling in Nalgonda and rain is falling in Hyderabad, then there can be a dependence. Why? Because Nalgonda is very nearby to Hyderabad. Some seasonal change in Nalgonda can have an impact in Hyderabad's weather also. Okay, that's what. If a coin is tossed, head on first fall, has no dependence. If head falls on the second toss. Okay. One more example which I have given to you. Rain falling in Hyderabad and rain falling in London. Okay. Now, next one, last and final theory. So very often you have seen Bayes theorem, correct? Bayes theorem is one of the cases in which dependent events come into picture. We denote dependent events as P, A, B. That means probability of A given B. Probability of A given B. What do you mean by this? Probability of A intersection B by probability of B. Okay. So now, yes, all of you, just recall your Bayes theorem concepts. If you are able to recall, then you are able to get this. Probability of A intersection B or probability of B intersection A. Both are one and the same. So probability of A given B is equal to probability of B, here we can write. Sorry, we can just cross multiply. Probability of A given B into probability of B is equal to probability of A intersection B, A and B. Okay. This is dependent event. So what is the good example of dependent event, if anyone of you can say me? See, here both are occurring. That means you want to go outside on a rainy day. You carrying umbrella is definitely dependent on falling of rain, correct? That is a very good example of a dependent event. So probability of A, that is probability of you carrying an umbrella, given that probability of B, that means rain should fall. If rain falls, then you'll take umbrella. If rain doesn't fall, you won't take umbrella. That is on rainy day. This is a classic example of dependent events. Someone meets with an accident, insurance company will give them claim amount if the accident happens. If it doesn't, so the probability of getting claim amount provided the accident should happen. Okay. So these are the examples of dependent events. You will wear a white dress if there is a dress code in your college. Probability of you wearing a white dress on Wednesday or on Saturday. Many of the schools in your school days also you know that civil dress or white dress on Saturdays. So or some t-shirt. So probability of you wearing that dress, given that it should be a Saturday. Okay. So all these are good examples of dependent events. Now let's start questions of probability. I'm giving questions on the board. Please, all of you try solving these questions and participate in this solving. Okay, it is very essential for you to solve questions. Okay, question number 1. All of you make note of these questions. Okay, I did not explain you some concept called sample space. Sample space is what when you toss a coin, one coin is tossed. What is the sample space? Head or tail? That means head comma tail. There are only these two can happen. So sample space is 2. If two coins are tossed, what is the sample space? Head tail, tail head, head head, tail tail. That means 4. 4 sample space. That means 4 probabilities. Okay. So sample space is nothing but total outcomes. Sample space is total outcomes. One more point, sum of the probabilities is always equal to 1. Probability of success plus probability of failure is always equal to 1. This also you should understand. Okay. Now write down the question and solve it. I'm giving you time. Come on, do this. I'm waiting, please. See, two unbiased coins are tossed. What is the probability of getting 2 heads? So let's solve these questions. Very simple questions. So see, when 2 coins are tossed, so I will line by line I'll solve. First I'll write the sample space. So sample space is when 2 coins are tossed, head head, tail tail, head tail, tail head. Correct? So 2 heads are how many? So 1 case. So 1 out of 4. So outcomes by total outcomes. Correct or wrong? Please tell me. What is the probability formula? Probability formula is equal to outcomes by total outcomes. So what is the outcome here? Two heads are only one. There is only one case where you find two heads. So 1 out of 4. Why 4? There are 4 like outcomes.
Outcomes.
One head. Hello. Anyone any doubts?
No, sir.
Okay. One head, one tail. How many? 2. One head, one tail. One head, one tail. So 2 out of 4. 1 by 2. All of you make a note of this. At least one head. At least one head. There are 3 cases. 1, 2, and 3. So 3 by 4. Not a head at all. There is only one case, that is tail. So 1 by 4. One head only. That means only this 2. So 2 by 4, that is 1 by 2. All of you make a note of this. We'll go for next question. Okay, next. Come on, do the next question. Do this. So two dice are thrown simultaneously. What is the probability of obtaining total score of 7? So you have two dice. Die 1, die 2. They're telling that what is the probability of obtaining total score of 7? So either 1, 6, 2, 5 or 6, 1. Oh. So I'm writing like in brackets. And then 4, 3, 3, 4, And then one, what more can be? So no other cases. We got 7 in all cases. So two dice are thrown simultaneously. What is the probability of getting a total score of 7? So outcomes are how many? 1, 2, 3, 4, 5, 6. 6 outcomes. So outcomes by total outcomes. So outcome by total outcomes, 6 outcomes, because the probability what we are looking is total score of 7, and total outcomes can be 36 because 2 dice, okay, not 1 die. 1 die the outcome is 6, 2 dice the outcome would be 6 square, 36, okay. So this is the answer. All of you make a note of this, because when you throw a die the total outcomes, when you throw one die the total outcomes are 1, 2, 3, 4, 5, 6. If you throw one more die the total outcomes will be what? For 2 dice the outcomes will differ, na? That is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, like that. So 36 outcomes you'll get. Question number 3. Two die are thrown at a time. See, you know how you get 36 cases? 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 2, 2, 1, 2, 2, 2, 3, like that, okay? Like that, 1, 2, 3, 4, 5, 6, 6 outcomes. Then with 2 6 outcomes, like that, 6 and 6 outcomes, so 36 outcomes. So you should know that basic. Two dice are thrown at a time. What is the probability that the sum of the two numbers is 6 or 9? Let me tell you something. Probability of A union B or A or B is probability of A plus probability of B minus probability of A intersection B. Okay, do this with, I have given the hint to you, and next question also I am giving to you. Yes, do these questions fast. See, two dice are thrown at a time. What is the probability that the sum of the two numbers is 6 or 9? Fine. So, two dice are thrown at a time. What is the, so outcome by total outcomes. So you see two dice are thrown at a time. What is the probability that the sum of the two numbers is 6 or 9? So if I take die 1, die 2. So here I should get 3, 3 and 2, 4. Okay. And 4, 2 and 5, 1 and 1, 5. Okay. So these are the cases 1, 2, 3, 4, 5. So if you want to get 6, the cases are 5 out of 36. In case of 2 die, total outcomes is this. In case of 9, die 1, die 2, like 4, 5 and 5, 4. And then if I have to see 6, 3 and 3, 6. I don't think any other case. So 4 out of 36. Why I am putting plus? Because or, and there are no common any common cases between them. So nothing is common to subtract. Okay. So directly if you see 9 by 36, it is 1 by 4. All of you make a note of this. We'll go for the next question. And these are kind of we can say are not mutually exclusive. What do you mean by mutually exclusive? If 6 falls, 9 will not fall, correct? So here it is like mutually exclusive. If this number comes, you get 6. If this number comes, you get 9. Okay, there is nothing common in them. That's what I want to say. Now let us take the next question. How to do this? Two dice are thrown at a time. What is the probability that the sum of the number on two dice is 10? So if I take die 1, die 2 and outcome by total outcome is the formula. So I should get 5, 10. Okay, 5, 5 and so any other case of 10? Only 5, 5. I see 6, 4, 4, 6. So there are just 3 cases. Okay. So 3 out of 36 for getting 10. That is understood. And what is the probability that the sum of the numbers on two dice is 10 or product of two numbers is greater than equal to 25? So greater than equal to 25 means there are two numbers. The final product can be 36. This is the final. It cannot go beyond this. Okay. So let's take the numbers which are bigger than 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So these are the numbers greater than or equal to 25. So equal to 25, 5, 5 we can take if we throw two dice. 26, no. 27, like I don't think 3 and 9 won't go. And like 7 4s are 28. This is not there. Yeah, 6 5, 5 6 and 6 5 for 30. 31 no numbers. 32 no, no, no and no and no. Okay. So 3 cases. if I am not wrong, 3 cases. Yes. Can you see any more cases? 9 3 6 3s are 9 3s are 7 4s are 6 5s are okay. 5 into 6. 36 is there, na? 6 comma 6. 6 comma 6. So 1, 2, 3, 4. 4 cases. Okay. So let us do one thing. Let us go and do this calculation. So n of A plus n of B minus n of A intersection B. Okay. So n of A is 3 by 36 plus n of B is 4 by 36 minus, for this I can write A into B. Okay, because A intersection B is A into B. And you know there is one thing common in this, 5 comma 5. Correct? And here also 5 comma 5 is common. So A into B is nothing but 3 by 36 into 4 by 36. Correct? So these are like events which are not mutually exclusive. Okay, they are not mutually exclusive. Correct? What do you mean by not mutually exclusive? Like happening of one, that means both the things cannot happen at the same time. Correct? So please calculate here. You'll get 9 by 36 minus 12 by, if I take like this, 1 9. Okay. So
7 by 36.
what?
3 plus 2.
12. Yeah. So if you solve with the LCM also, it will work out. 3 by 36 plus 4 by 36 minus 1 by 108. So 36 threes are is 108. Okay. Nine plus 12 minus 1 by 108 is how much? 12 plus 9, 20. 1 minus 120. So I'm writing here 20 by 108, that is 5 fours are and 27 fours are. So the answer is 5 by 27. All of you make a note of this. Okay, so all of you today like do these questions, and I'm not giving any worksheet. Tomorrow I'm going to take the class between 2:30 and 3:30. 2:30 to 3:30 you have session. If I am available from 2, I will take from 2 to 3:30, and evening also I'm going to take from 7:30 to 9:30 tomorrow. So afternoon 1 to 1.5 hour, evening 2 hour. Probability will be done in the afternoon time, and evening I will be taking up a big chapter and finishing it tomorrow. Okay. And one topic from reasoning, that is puzzle test. That also in evening I'm going to cover. So 3 topics tomorrow you're going to get. So be ready for the class tomorrow. Okay. Thank you all of you.
Okay. Thank you, sir.
Yeah. Thank you. Thank you.
Bye.
Bye.